Welcome to all in the GSM Frame Structure course. In this course, objective of the course is basically we will cover how the information is transmitted on the air interface. That is the basic concept, and it is covered the mainly frame structure in terms of burst and frame, multi-frame. These are the hierarchy on which our logical channels or control channels, traffic channels are transmitted in the form of burst. The whole objective of this course is the how logical channels mapped on the physical channels, and then what are the sequence of physical channels that is transmitted one by one in the structure of multi-frame structure or super frame structure, right? In this course we will discuss the GSM logical channel, then physical channel. The information transmitted on this physical channel is known as burst, and different types of burst is there, right? Frame, multi-frame, super frame, hyperframe. And after the understanding of multi-frame, super frame, we will discuss the how the logical channels is mapped on this multi-frame structure. And finally, we have one quiz for completion of this course. Let's start this course. We will start actually understanding about the logical channels. Then we could understand the how to map this logical channel to onto the our frame structures. The two types of logical channels there: common channel and dedicated channels. And within the common channel, it is a broadcast and common control types of channel. And broadcast type, they are in the GSM network: frequency correction channel and synchronization channel and broadcast control channel. These are the three channels, broadcast channels, that is used in the GSM network. And what about common control channel? It is a paging channel, SS grant channel, and random SS channel. These are the three channels that is used as a common control channels. Commons means the cell is, this channel is used for more than one user's equipment. And broadcast channels means it is used in the cell, all the cells of the users. Okay, the first thing, that is the common channels is always in unidirectional. Unidirectional means either it is a uplink or downlink. The common channel is always unidirectional, and dedicated channel is always bidirectional. Let me, common channel is always unidirectional, and this dedicated channel is a bidirectional. Suppose this three channel broadcast channels always in the downlink. Bidirectional means there are two link is there in the any mobile network: uplink and downlink. When your mobile station is transmitted the signal, that is uplink. When the mobile receive the signal on any frequency, that is downlink. Broadcast channel is always downlink. Paging channel is always PCH. Paging channel is always downlink. A write channel, that is the request channel by the MS, that is always uplink. AGCH is the always downlink. That means common channel is always unidirectional channel, and dedicated channel is always bidirectional, right? Within dedicated channel, the dedicated control channels and traffic channel. These are the dedicated channels between the UE and base station, BTS. So three dedicated control channels are here: SDCCH, SSCH, FSCH. SDCCH means it is very important channel, logical channel. That is the standalone dedicated control channel. Standalone dedicated control channel. SSCH means slow associated control channel. FSCH means fast associated control channel. And traffic channel, as all we know, full rate and half rate. Traffic channel, full rate and half rate. Right. Now What is the use of this logical channels? First is the search mode, then idle mode and dedicated mode. Some of the channels used in the search mode, when you switch on your phone, the phone is searching the frequency, that is the frequency correction bus, that is the FCCH. This channel use, right? Sorry. And search for synchronization. Second is the SCH logical channel that is used for the synchronization of the frame in the GSM network. And BCCH channel basically used for the read the system information. Read the system information like LAI. Different types of information is there, broadcast information, that is BCCH is transmitted to the UE. And paging channel, that is listen for the paging when any incoming call is there. The paging channel first comes, then UE respond against their paging channel, right? Random access channel, that is sent when we want to initiate a call. And AGCH is a access grant channel. That means against the RAJ, AGCH is transmitted by the base station, that is assigned of the, it means it is an assignment of the AGCH channel. Within AGCH, there is a AGCH allocation address is there, right? And this is used basically for call setup. And FSCH is used for the traffic channel is assigned. And also FSCH is used for the call release. FSCH is also used for sending the handover command, right? And TCH is used for conversation, your actual user data transmission. Correct? These are the logical types of logical channel and what are the use of these logical channels. Now we comes on the physical channel and logical channel. What are the physical channels? The physical channels basically is the medium over which our information is carried, right? That is our carrier. What is the carrier in GSM? 200 kilohertz carrier. And what are the physical time slot? That is the 577 microsecond, or we can say 0.577 millisecond. The logical channel consists of the information carried over the physical channel. Okay, different types of logical channel means the different types of information is carried on that physical channel. And the information carried in one time slot, right? Time slot means 0.577 millisecond is known as burst. What are the information in this time slot? This information is known as actually burst in the GSM network. And what is TDMA frame? There are consecutive 8 time slot combined, and this time period is known as the one frame in the GSM network. One time slot and 8 time slot, combining 8 time slot, that is known as the frame. And this frame is repeated one by one. And this frame number is actually transmitted in the synchronization channel frequency. Okay, frame number is transmitted in the synchronization channel. And we can see here the different types of frame and multi-frame structure is there. There are two types of frame and multi-frame structure. First one is the control channel frame multi-frame structure, and second one is the traffic channel frame multi-frame structure. We can clearly see here 51 frame multi-frame. This one is the structures. Okay, frame structure is used for the control channel, BCCH control channel, right? We will discuss BCCH control channel. That is the also, if we go, that is the non-combined mode BCCH configuration. Okay, so these are the sequence of logical channels that is transmitted on the different frame multi-frame structure. In one multi-frame, there is a 51 frame in case of control channel. In case of traffic channel, there is in one multi-frame, there is a 26 frame is there. Okay. And this multi-frame structures is continuously repeated on super frame and hyperframe. So simple, right? This sequence, this is the basic sequence actually. It is fixed, and this fixed multi-frame structure is repeated on which super frame and hyperframe structure in the whole actually this one. This is the overall view actually. In the top of view na, you can see everything, all the hierarchy in the frame structure of GSM network, key burst, time slot, frame. Okay, so one by one we will discuss here. And the top of this you can see here the four burst is there. Burst means what are the information you are transmitting in the time slot. Four types of burst is there: normal burst, frequency correction burst, synchronization burst, and SS burst. One more burst is there known as the dummy burst. Na? When there is no information transmitted, a format of dummy burst is also there that will be used sometimes. Okay, so these are the four main bursts when there is any information is there. Okay, first one is the normal burst. So basically, normal burst is used in which case? In the traffic channel, in case of dedicated channel. All the dedicated channels are used as a normal burst. And what is the importance of normal burst? Normal burst, normal burst basically uh, send the complete information not in one burst. It a consecutive four burst is required to send a complete information. To send a complete information. Why? Because you can see here encrypted bit 58 bits, 58 bits, because they are interleaving. The information of complete message, na 20 millisecond information is interleaved in four bursts. Okay, they are not transmitted as sequence number of bits. Na, they are interleaved. Interleaved means time diversity. Na, the bits are scattered na in different bursts. So it is very important to receive four bursts, consecutive bursts to decode the complete information. That is the normal burst. And for all the dedicated channels, the normal burst, the information is transmitted as a normal burst. And this frequency correction burst, synchronization burst, and SS burst. These are the specific bursts is used for specific channel. Okay, frequency correction burst is used for frequency correction channel, control channel, right? Synchronization burst is used for synchronization channel, and SS burst is used for SS channel. SS channel means random SS channel. These are the three specific. The format is different, but the normal burst for all the dedicated channel and BCCH channel is also the normal burst is used. Information transmitted in the form of normal burst. Okay. The first thing is the burst that is transmitted in one time slot. Now, the time slot duration we have already know 0.5577 millisecond, and one time slot within one time slot, what are the number of bits? 156.25 bits is transmitted, right? And continuous 8 time slot, we consecutive 8 time slot make a one frame that is known as the 4.615 millisecond. Now we can see here the different multi-frame structure. Na? Different multi-frame is, we can see here, this one is the traffic channel multi-frame structure. Means the structure of this multi-frame is different for traffic channel, and structure of this control channel is different. Structure of how they are mapping. Actually, we will discuss the mapping of different logical channel onto this multi-frame. We will discuss in subsequent slides. But here we can clearly say the multi-frame, after frame, na, the multi-frame structure is different for control and traffic channel. For traffic channel, it is a 26 frame multi-frame structure, and for control channel, it is a 51 frame multi-frame structure. How many frames is there in one TDMA frame for control channel, that is the 51 frame, and how many frame in the multi-frame of traffic channel, that is the 26 frame. If we know the duration, that means the 26 frame multi-frame, what is the duration? 120 millisecond. If we multiply one frame duration into 26, it will becomes 120 millisecond. If you multiply the 4.615 millisecond into 51, it will become the 235 point something millisecond, right? So these are the frame duration, multi-frame duration, that is different for control and traffic channel. Now we come on the after multi-frame, that is super frame. The super frame duration is same for both control channel as well as traffic channel. Duration is same for both the frame control plane and control and traffic structure, right? Multi-frame structure. That is the duration is the 6.12 second. How they are same? Because 26 frame multi-frame per traffic channel, they are taking the 51 multi-frame of this traffic channel multi-frame, and in one super frame we are taking the 26 multi-frame of control channel multi-frame, right? If you multiply 26 into 51, right, and here we can multiply the 56 into 26, it will become the same, na? The number of frame is same in case of super frame for all the, whether it is a control channel or a traffic channel, that is equal to 1326 TDMA frame. Now super frame is clear. After super frame, the 2048 super frame, consecutive 2048 super frame becomes the hyper frame. And how many frame is there in the super hyper frame? You can see here the 2,715,648 TDMA frames. And the duration of that hyperframe is the 3 hours 28 minutes and 53 seconds and 760 milliseconds. These are the duration of the hyperframe. Why it is important? Because this number, this 2,715,648 frames, actually these are the maximum number of frames that is transmitted in the synchronization channel. F1 max. After that, 2,715,648 number of frames reset and becomes 0. The maximum number of counter in the synchronization channel, that is the 2,715,648, right? So these are the frame structure. Bosch or TDMA slot or frame, then frame becomes multi-frame, multi-frame becomes super frame, and super frame becomes the hyper. These are the structure. Now the channel organization in the traffic channel. We will discuss both of that. First, we will discuss the traffic channel. It is very important, right? 26 frame multi-frame. In the for full rate, there are two cases. Case one is the for full rate channel structure, and case two for half rate. When there is a half rate traffic channel, then what is the structure of bus structure? How they are transmitted into 26 frame multi-frame? It is very important, right? The first we will discuss the full rate. The 26 frame we can see here, this is the, suppose any time slot burst period is allotted to any user. Suppose time slot 0, right? 0 time slot is allotted. Okay. In one frame, how many microsecond is allotted? 577 microsecond. 577 microsecond. In this period, user transmitted their signal in the form of burst. Okay. In the next frame, again, time slot given to the user and they are transmitted their signal information in the form of burst. That means total 26 frame you can see here. This is the frame. One frame. In one frame, one time slot is allocated to the user. In second frame, One time slot is allocated to user. In third frame, one time slot is allocated to user. Likewise, total 26 frame is there for full rate, and last frame there is no information transmitted in case of full channel, TCH full channel. Okay, this is a idle frame. And this one is the SACH frame, SSCCH, I have already discussed here. Na? SSCCH it is a dedicated control channel. It is used for transmitting the different types of message in downlink and uplink, na? For measurement report and all timing advance and power control message are sent on this SSCCH channel. And this one is the 13th frame, middle of this multi-frame structure, 26 frame multi-frame. And this sequence is fixed for traffic channel full rate. This sequence is fixed. Frame 1, the traffic bus is transmitted. Frame 2, traffic bus is transmitted. Frame 3, traffic bus is transmitted. Likewise, na? And 13, SACH bus is transmitted. And all likewise, na? In last, it is the idle frame. It is a fixed sequence of the bus in the case of traffic channel multi-frame. And this multi-frame structure is repeated on super frame structure. Nahin? In super frame structure and hyper frame structure. Now comes on the half rate. We can see here the now in the same time slot two users come na. In the first frame, user 1 is transmitted their signal. In the second frame, second user comes. In third frame, again first user comes. What is the difference between full rate and half rate? In the full rate, we can see the time slot or burst allocated to the users, or we can say scheduling period is 1 frame. After 4.615 millisecond, user gets the traffic channels to send their burst or information. But in case of half rate, the users get the time slot, but scheduling period is changed now. There are 2 frames. The scheduling period is the 4.615 into 2. That means 9 point something millisecond that is used to transmit or scheduling. Na? First users get the time slot, and after 2 frame they will get again this time slot for transmission of their burst. And then after 2 frame you can see the scheduling period is a 2 frame now in case of half rate. Sorry, this one is the control channel. It's not traffic channel. Okay. And this channel actually basically this SAT is used for the user 1. Now the second user comes same time slot but different frame. First frame user gets 1, second frame same time slot but frame is different. Second frame user 2 gets, fourth frame again user 2 gets, sixth frame, eighth frame, okay, likewise. But idle frame, in case of full rate, here this idle frame is used for the signaling channel SSCCH for second user. Transmission of signaling message to second user in case of user is dedicated mode. All the SMS you are getting in the dedicated mode, that is comes on the slow associated control channel. These idle channels is used in the case of half rate by the second users. This is SACH is used for the second user. Okay, this is the basically case of full rate and half rate, how the traffic channel bus structure is there within the 26 frame multi-frame, and this 26 frame multi-frame is repeated on the super frame and hyper frame, right? Now the structure, channel organization in 51 frame multiframe. 51 frame multiframe, right? We can see a downlink, uplink, right? So this one is the control channel frame multiframe, 51 frame multiframe for which channel? Control channel and broadcast plus CCH, BCCH and CCH. This is a channel organization for non-combined. Non-combined means the BCCH, common control channel, and dedicated control channel, HGCCH, are separately allocated in the frame in the different time slot. Right? This is the case here. This is the sequence. What is the sequence of the logical channel that is transmitted in the 51 frame multi-frame in the downlink direction? First one is the frequency correction channel. Frequency correction channel burst. Second is the synchronization, right? And then continuous 4 burst is used for broadcast channel. Why continuous 4 burst is used? Because it is a normal burst, na? Normal burst is used to transmit the message in continuous 4 bursts because the message is interleaved between the bursts, right? Second burst, 4 bursts is used for control, not control channel. It is a control plus common control channel. Basically, it may be used for paging channel and AGCH channel. AGCH. Okay, then again, same frequency correction channel and synchronization. Then again, one block means 4 bursts of CCH common control channel. Then again, four bursts of common control channel. This consecutive 4 bursts is known as the block. Total 9 block is there for common control channel, and total 5 in 51 frame multi-frame. Total 5 bursts is used for frequency correction channel. 5 bursts is used for synchronization control channel, right? And one block is used for broadcast control channel. So these are the total frame structures, how the logical channels is mapped on this structure, multi-frame structure, 51 frame multi-frame structure. And last frame is used as a idle. This is the downlink scenario for BCCH plus CCH. This is the common control channel. Now all this BCCH is the control, right? Common control channel. This is the dedicated. This one is the second is the dedicated control channel, uplink and downlink. And what is the common control channel for the uplink? There is only one channel is there in the uplink. That is the in the all the uplink frame, 51 frame multi-frame. It is a RACH channel is there for uplink. There is a RACH channel. Okay. And what is the duration of that? 235.38 millisecond. This is the continuous. This repeated. Na this multi 51 frame multi-frame is repeated on the super frame and hyper. Okay, but within a multi-frame structure, the position of all the logical channel is fixed. All the logical channel is fixed. Now the HDCC dedicated control channel, what are the information is transmitted of the standalone dedicated control channel? Okay, here we can see na HDCCH and SSCCH all are transmitted in the form of normal bus. The normal bus, when where a normal bus is transmitted, they are transmitted 4 consecutive bus. 4 consecutive bus means this one is the D0 is the continuous 4 bus. Na the 4 bus make a one block of HDCC channel, right? One block, two block, D0, D1, capital D2, D3, D4, D5, D6, D7, right? A0, A1, A2, A3, and last 3 frame is the idle frame. Last 3 frame is the idle frame. This is the fixed actually for the SGCS, na, we logically can say the it is a 102 frame multi-frame. Why we can say 102 frame multi-frame? Because the same structure we can see, na, D0 standalone dedicated control channels is the repeated in whole 51 frame multi-frame, but your SACH is also associated with the traffic channel as well as the SDCCH. So D0 is associated with the A0, D1 is associated with the A1, A2 SACH, A2 is associated to the D2, and A3 is associated to the D3, right? A4 is associated to the D4, but SACH this na comes in the next 51 frame multi-frame. That's why the SDCCH channels in the non-combined mode. Combined mode, it is a 51 frame multi-frame structure, but in the non-combined mode, it is a 102 frame multi-frame structure is there. 102 frame multi-frame. We can clearly say A0 SACH from A0 to A7 comes, complete message comes in the 102 frame multi-frame structure. And this 102 frame multi-frame structure is repeated on the super frame and hyperframe. Right? This one is the control channel format structure. Okay. This one is the last slide. Now these are the some abbreviation that we have used in this session. Thank you to all, and now proceed for the quiz. Okay, thank you.